Okay, so the first thing that we're going to start with is well, okay, for overview, we're going to try to use the Jupyter Notebooks, which is an interactive tool to write and document code. However, the prerequisite for that is Conda. So so if you go to this this URL that I'll drop in the chat, then you can download Conda for your operating system. There's pretty minimal requirements, assuming you have 400 megabytes of disk space and like any computer that is currently being produced. So yeah, go to your operating system. I use Windows, so I would go for the mini Conda installer for Windows. You can do Anaconda and it will do the same, but I recommend mini Conda because it's a lightweight version that has fewer tools but will satisfy the goals for today. Yeah, so go ahead and install that one. And again, I recommend Python 3.8. And most people have 64-bit systems, but if you're not sure, go check your system. But yeah, this is what I would have clicked. So, and while that's running, so, well, what is Conda? Well, Conda isn't really much software itself, but it is it's a package installer. So the only thing we're going to use Conda for, or Anaconda or Mini Conda, is to download Jupyter. That's the only thing, because this is the best way to download Jupyter unless you already have pip installed. In that case, you might use that. These are both just package managers. So once you have Conda installed, then you would go into like the Anaconda prompt, and it will just show this terminal. And all you would do is copy this into the terminal. I actually don't think this supports copy and paste. So you just write it as such. Okay. So is everyone caught up so far? Give me like some thumbs up on screen or in the participation window when you're all caught up. Oh yeah, let me also send this. Even well, the command is on the screen, but just in case you want to see it. Okay, and so is anyone still installing Jupyter? Okay. So once you have that, you would go to your start menu and open up Jupyter Notebooks. So once you have that, it'll open up this command prompt, and then it will open up this this directory. And so that's where you want to be. So right now we're going to work with this repository that I found from this video by Free Code Camp Online. Okay. So let me send this to the chat. Yeah, installation is kind of like a itself is almost a little bit of confusing process, so that's why I'm giving it a little time to spend here. So with this Git repository, you can download this entire directory onto your computer by just doing download zip and then extracting the zip. So okay, so yeah, code and then download zip, and then in your own directory, extract it. So so I have it in my desktop dev in this folder right here. So, so I would go to that directory from here, which is, let's see, desktop, is it desktop? Oh, yeah, OneDrive desktop. Okay. And in this folder, there is a file called lecture1 itynb. Okay. And this is the interactive notebook that we'll be mainly using. There's actually one other one that I want to go on first, or two other ones. So is everyone caught up this far? Or is anyone have any questions?
Still working on it, sorry.
Okay, no worries. Okay, so here's the one we're actually going to work on. So go to this one and do the process as before, which is download the zip and extract. And then once you have that directory open, go to that folder, which should be called Intro to Numpy Master. And Numpy is the first tool that we're going to look at. Okay, so so I understand that people might be still taking a little time to work out the kinks of this. So while we're doing that, I also have like a little side presentation, or like a short overview of what we're going to be looking at. Okay, so just like some exposition and context, like, well, what is data analysis? Data analysis is a process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information, informing conclusion, and supporting decision-making. So the tool that we'll use to inspect, clean, and transform is Panda. So just all forms of like looking at data and manipulating it as well. Modeling data means adapting it to real-life scenarios and making inferences to see if any patterns arise, which is the intersection of all pandas, matplotlib, and seaborn. And we transform data into information. The difference between data and information is that data is just numbers and like, I guess, cold hard facts and statistics, whereas information is like what you make of that and like the conclusions you can draw from data. And typically, if you're a data scientist, or at least doing this as part of your job, your clients will need a realistic and understandable summary of the results. So we have auto-managed closed tools, such as Click, Tableau, Looker, and we also have programming languages like Python, R, and Julia. Okay, so these auto-managed closed tools, they're more visual. They will have they have like all the packages and libraries installed and provide nice interfaces. But programming languages are just the languages on their own. So the characteristics of these closed tools, well, they're closed source, so they're owned by a company typically. You have to purchase them, they're expensive. They may be limited in their abilities, but they are easy to learn and they're very visual. They have visual interfaces. Whereas programming languages like Python, well, they're open source. Anyone can use it. No one owns Python, not even the creator. So, and they're free. Anyone can use Python or Julia. And powerful, meaning that you can do anything with them. They give you the added flexibility that these like closed interfaces might not offer, but they do have steep learning curves and they're not visual. They're like it would just come out as code. So we're going to look at Python, of course, which is a programming language. But realize that we're performing a similar thing that you can do with Excel. So if you open up a data set on Excel, we're going to be looking at very similar things to that. So more motivation for like why Python? Well, as covered before, it's simple and it is intuitive to learn. And well, it is the industry standard, which is what we mean when we say it's a correct language. It has a powerful library support with a community that's constantly improving it and creating resources for it, free and open source. Anyone can use it without paying. And yeah, as I said, amazing community, conferences and whatnot. This is what the process of a data analysis will look like. First, you have to get the data, which is abstraction, maybe from a database, from web scraping, or from a format like CSV, which is comma separated value, JSON, or any other forms of data. Then the next thing you would do is data cleaning, which is filling in missing values, dealing with like empty rows, empty null values, incorrect types, or things that are outliers, like dealing with those in ways that would make sense for the context of your project. Then there's data wrangling or manipulation, which is just reshaping it to like prep it for analysis, like reshaping and indexing. So, and then analysis is the penultimate stage, which is actually building models, examining correlations, and testing hypotheses. And then with that analysis, you can perform the action that is acquired from the information that you get from the data. Okay. And yeah, that's all for background. So hopefully you'll have are able to get here, which is in the Numpy master folder, and it's called to Numpy IPYNB. Okay, and that was from the second repository I sent. But if you haven't gotten there, then don't worry too much. I might be able to help you afterwards, but you can also tune in, and I think it'll be almost the same experience. Okay, so Python. Oh no, this is one. This one. Okay. Okay. So NumPy is the first library that we're going to look at, and it's, well, let me read. It's a core package for numerical computing. It's often used for matrices, but it's really for anything that's we want to be like fast and low cost. In Python, when we create numbers, we don't create only the number, we create the entire object, which contains all the information, like how would you perform operations, and how would you like add or or do any other functions on like that object, which is a number. But NumPy simplifies that data structure to be like the very basic like binary. So that's why NumPy is fast, because it deals with less data. And then it has these contributions as well. Well, it's so C primitives, that's like binary, and an integrated and natural linear algebra API. So like I said, working with matrices, and an API is applied, applications, programming interface. Yeah, and for, so it has an interface for libraries written in other languages that are, well, these languages are faster than Python. Python is easy, but it's slow. That's why we don't typically use it for performance. But NumPy is to help alleviate that. So, so the first thing you would do, and well, if you attended last workshop, then this should look really similar as well. Well, we have these code blocks that you can run, and we also have these markup blocks. And for example, here's a double hash that so that means it's a second header, and it's showing that this is the title of this section is called hands-on. So whenever you want to run code, you would click this run block or do Control Enter. So actually, I want to clear all outputs. So I'm going to do that by all outputs clear, just to give the element of surprise. So let's perform some operations. What we created here is a Numpy array, and it's basically just a list, but as a Numpy object, which is lightweight. So by running this, we just output the array itself. But this creates the array, but then it immediately gets erased because it is not stored in memory. So we can store it in the variable a, and that means a is equal to this object. And we can also do the same with b for this other object. There is no output since that's just an assignment. So if we get the value at a at 0, at index 0, then that's 1, and index 1 is 2. Here's some syntax for 0 : means from 0 until the rest of the Numpy array. So from 0 to the rest of the array is the entire array. This here means 1 : 3 means the array from index 1 to index 3, but including 1 and excluding 3. So the first is inclusive, the second is exclusive. So that's why it gives from, index 1, which is 2, and index 2, which is 3. And and then this one here is, this is from index 1 until the last one. -1 means the second, this means the last index. So here's some more that I'm gonna breeze through. This skips, : 2 means skip every other index. Okay. So as we've been performing these indexing, we have not changed the value of b. So b is still the Numpy array that we've assigned it. And here's one way well, this creates, well, this does not create, but it displays a list of these 3 values: b at 0, b at 2, and b at the last index, which is 2. So that's 0, 1, and 2 as floating point decimal values as expected. And this one here, this is a way to actually create it as an array. Okay, so we'll go on to array types. So we have a from before. If we want to get the data type of a, then we can perform this, and this gets the attribute of a. Well, this is an attribute. Remember that attributes belong to objects. So a is an object, and it has the attribute d type, and the attribute is int32, which means that it's a 32-bit 32-bit integer. Let's do the same thing for b. B has values that include decimal points, which is why it's a floating point value, and it's 64 bits. So twice as much data as this integer.
Hey, David.
Yes?
For my code, it says NumPy isn't imported. I'm not exactly sure.
So that means that you need to run this instruction here.
Yeah, I tried it, and it says there's no module named NumPy. I think. Do I have to run it on like?
Oh, you didn't install NumPy.
Oh, I have to install NumPy. Okay.
Yeah, using the Anaconda prompt.
True.
Okay. Let's see. Let me search up the NumPy installation. Does anyone else have that problem? Okay. So in this link, so let me share. This gives the command to install it. You would run this in the Anaconda terminal, and yeah, do conda install Anaconda NumPy. Okay. Yeah, that's generally how you would handle that situation. Just download it and make sure you download it and make sure you import. Okay. So okay, so back here we have here's a way to declare a NumPy array with a specific data type. Even though we input integers, it interprets it as float and it adds decimal points. Okay. Okay. So these are just ways of manipulating types. I don't want to spend too much time on this since it's all kind of bare bones, but I will look at this dimension and shape. So we create a NumPy array and it can be of 2 dimensions. And this gives a lot more flexibility. Okay, so the shape, now we introduce the concept of shape, which is, in this case, it's 2 by 3 because there's 2 rows and there's 3 columns in this NumPy array. And since there's rows and columns and the dimension is 2, so we have the attribute ndim, which is n dimension. And the size will be the number of elements in this 2-dimensional array. All right, so we have a 3-dimensional array here, which is B. And if we get shape, well, there's two subarrays with each with 2 columns or 2 rows and 3 columns. Okay, so that's how you get the shape. There's 3 dimensions here, and the size is 12 because there's 12 elements total. Okay. What if the shape is not consistent? Then we'll fall back to regular Python objects. Python, so NumPy does not handle uneven arrays. As we see, this one has 2 rows in this dimension, but this has 1 row in this dimension. So if we try to run this, we will encounter an error. And the data type is now object. So how is that different from before? What if we try to get the data type of B, which was a valid NumPy array? So D type. Okay, and then this is actually an int array. An int array is more lightweight than an object. Remember, objects are technically speaking heavy. So and the shape is 2 for the first dimension, but it's undefined for the rest because the rows vary. But the size is 2 because in Python, in Python lists, which is what this is, the size will just be the size of the outermost array. Okay. Yeah, so we have a list of lists. Okay. So this was just like kind of a taste test of like, well, what can you do in NumPy, and what are the most basic foundational operations that NumPy can accomplish, and these are some examples here. So now we're going to move on to another short tutorial in the next tool that we're going to look at, which is Pandas. So I will share one more Git repository, and I promise that this is the last that you will have to download. Okay, so chat is not okay. Okay, and so once you extract it into a directory, then it should be called free code camp intro to pandas master. Okay, and the directory that or the file we're going to open is pandas series ipynb. Okay, so we're done with NumPy for now. Okay, as a side note, ipynb stands for Interactive Python Notebook. This is not a Python file. This is an interactive Python file, which can include documentation and code run in blocks. And this, I believe this can only run on Google Colab and Jupyter Notebooks, but there may be other applications that can run this too. But typically, if you're actually running this in a real application, then you would just have a Python file, and that is just file name.py.
We have to install pandas for this too.
Yeah, I think the problem was that the mini conda didn't come installed with everything, or yeah. So what would that look like? Conda. Yeah, so it should be this command here in the Anaconda prompt.
Alright, cool.
Okay. Done with this here. We're done with this. Let's put a layer. Okay. So back to pandas, and thanks for the question, Billy. Yeah. Well, so pandas is it's probably the most powerful tool and the one that you'll use the most frequently for data, because it deals with like most of the data manipulation and the manipulation, fetching data from like a file, and also like visualizing it. And pandas builds upon NumPy. So we actually don't use NumPy much itself, but it was worth showing what it was capable of, because pandas and matplotlib are built off of NumPy. NumPy is yeah, again, that's the foundation of these. So we'll import, and we will introduce the most common data structure, or at least the one we're going to use here, which is the series. So we'll create an object here using this syntax, which is PD, which is pandas. That's the abbreviation that this import declares. So when we say import pandas as PD, we're saying that we'll shorten pandas to PD. So if we did this, if import pandas, then we would have to write this out as before. And that's how we say that this function belongs to this library. But yeah, I'll leave this as the abbreviated, since this is more common. Okay. So we have a series here, and as you see, it's just a sort of array-like, list-like data structure. And this one is storing some decimal values. And well, it says that it's in millions, and this is representing the population of Canada, France, Germany, and these countries here. So if we run this one, then we'll show the populations for each index in the list. So this is just displaying the contents of this series. Okay, we can also change the name. That has no output, but once we run it here, then it'll also have this attribute name. This is an object, and it has all these attributes, including the values, the name, and the data type. Okay. I'm gonna clear all the outputs and rerun this. Okay. So yeah, we can fetch only the data type, which is a floating point. And so floating means it includes a decimal. We can only get the values here. And if we actually fetch the type of the values, well, there it is. There's a NumPy. So right, I said that Pandas is built on NumPy. They're backed by Numpy arrays. So, okay, so let's perform a few other operations. We can index as before. So this was the first element, this was the second. This shows the range of indices. Okay, and here's just a basic list. But what we can do is we can define the indices using the actual values. So we said that this is meant to represent the populations of these countries. So this is how we replace the indexes with the actual countries. So now instead of it being 0, it'll be Canada, which is the position at 0. So if we run this and we show the series, now these indices are replaced with their actual values, and that's more descriptive, and this is more visual. Okay. So this isn't the only way. You don't need to necessarily display or create the series and then like add on the indices, like define them afterwards. Here are some ways that you can do it at once, which are index colon value. Okay, and you can also define attributes as follows. Okay, and here's yet another way. Okay, and so what does this do here? This is a subset of the list, but only at these indices, which are France, Germany, Italy, and Spain. So this is just a subset of the original list. Okay, so quick note, this syntax may be intimidating and this may be confusing. So I think that with anything but data analysis, there's a large culture of looking stuff up. As in the previous workshop, I was trying to build an intuition of syntax that would be great to be familiar and to have to your vocabulary. I think even for data scientists, they may not have these on the back of their hands. So the most important thing is to understand how they work and not care too much about exactly how it's written, because you can always find that in documentation. Okay, so you need not concern yourself with those details. Okay, so I think that this is just more fluff. But I do want to show a few things. So if we so that's the original population series. This is the population only at Canada. So that returns this population here for Japan. And this is a way you can use the numeric position instead of the countries that we defined. So, and then as before, -1 means the last one, which is United States. Okay, here's one way that you can select multiple elements, and this accomplishes the same thing, although with the indices, again with the ILOT, which it seems to be index location, and slicing, which is everything from Canada to Italy. And it's interesting that this is inclusive of Italy. Yeah. Okay, so that's all for pandas. A lot of data will be in this format of series, and this is convenient to work with when we have data like this. So we're gonna get into actual working with data sets now. So the one that I accidentally told you to download first is called Free Codecamp Pandas Real Life Example Master. So you should already have that ready. We're going to go to lecture 1, IPYNB. Okay. Okay, any questions so far? Any question on the pandas, for example?
I had a random question, not like relating to either one, but there was, now it says dtype, and then it says like integer or float, and then there's a number after that. What does a number
Yeah.
represent?
The number represents the size of the well, do I want to say variable? Is variable the right name? I guess, yeah, just the size of the data type, like how much it occupies in memory, which is 64
okay.
bits. Yeah, so that's like in binary, 64 bits. So we can have like, maybe if this were like positive integers, that would be like 2 to the 64. It can represent like 2 to the 64 different values.
Oh, okay.
Yeah.
Cool.
So you usually want to have, I guess, like as small a data type as you need. Okay, anything else on pandas? Okay. Okay, now we're going to actually play around with data. So this was all really rudimentary so far. Let's actually try out a data set. Well, okay. So again, let's make sure we have everything here. We already downloaded NumPy and pandas. I'm assuming the next one is called conda install matplotlib, but let's find that out too. Okay. These all seem to, it seems like these all work. Okay. So we're going to look at a data set that's byte store sales first as an example. And we're also going to try other data sets to wrap up this workshop. So yeah, here's the import. Again, NumPy as NP, pandas as PD, and matplotlib as plot. Just other ways to abbreviate. I was a little curious what this was supposed to do. Since this is since it has an exclamation mark, I think that means that this is a command line command. If it doesn't have an exclamation mark, it's Python. So, but I'm not sure what this is due because I'm not familiar with this command. But it seems like it doesn't matter. What we do first is, well, we have this file in our directory. If we look back, there is a file in the data folder called salesdata.csv, which is comma separated values. And well, this function that is part of the pandas library reads that data. Well, what happens if we look at this? Let's find out what this value actually looks like. Okay, well, we can open it with Excel, and this is probably the typical way to open it. And we can see what the data, what it looks like. Okay, so and this is a huge data set. This is absolutely ginormous. If I kept on scrolling, I wouldn't be able to finish this today. So that's why we have programming languages, because the visual interface that is Excel is not enough for the size of the data set. Okay. So we read this file into this object, and once we do that, now we have a set of functions offered by pandas that can allow us to play with this data. Let me clear everything. Okay, so the head. Okay, so let me run this again. Okay. Okay, so sales.head will return the head of the data set. So this is just a way to get like a sample, like what kind of data are we looking at? This is just like intuition check, like, okay, well, I'm definitely looking at the bike data now. It talks about categories, which includes bike rats, costs, and these other things related to sales, to bike sales. Okay, so and this is just to make sure that you have the right format. And what we have here is sales shape. So we saw shape in another context, which is the Numpy array shape. Now we have a similar attribute here, but this isn't for Numpy arrays. This is for the Pandas object. And the shape is the number of rows and the number of columns. Well, there are 18 columns and there are 100,000 rows approximately. Okay, so this is a huge set. And info, well, why does info have a parentheses while shape does not? That's because shape is an attribute, meaning it's just a data affiliated with the object as part of the object, whereas the parentheses means that it is a function associated with the object, which means that it's a series of code, it's a series of instructions we execute, and it returns this. So what does this actually have? Well, this has info about all of our columns. You know, well, it says the names, date, day, month, etc., and the number of non-null values. Null means that there is no value for that attribute or for that column, I mean. And everything is non-null, which is great. So if there were null values, then you would need to, and they were important. If they were important, then you would need to remove those through cleaning, and you would need to remove items from the data set where there are null values, because you won't be able to perform computations on null values. So so it's great that this has no null values. And then lastly, it's a data type. And here we have a special one called datetime, but we also have integers, objects. Strings are listed as objects. I don't quite recall why, but it seems all the strings here are objects. Okay, and everything else is in int. So that's details about the columns. Okay, so what if we wanted more information about these columns? Well, we can use the describe function as part of Pandas, and we can get details about all of our data about each column that is a numerical value. So we have day and year, which are numbers. We do not have month because that is that is an object, which is a string here. So so we have a lot of the essentials, which are like the count, the number of values, the mean. Well, maybe let's look at something meaningful. The mean price of sales at this bike store is $453 with a standard deviation of this much. The lowest cost item is $2. The item at the 25th percentile is $5. And 50th is 24. There seems to be a huge item which is driving the mean up really high, and that must be the item that cost $35,000. So yeah, that's how one way you can interpret this. Okay, so we are using Pandas for this, like we did in the previous IPYNB file, and this syntax should look familiar, right? We have the Pandas object at this index, which is the unit cost. So remember how we indexed by countries before? Well, similarly, we're indexing by the cost here. Okay, and we're taking this column, which is unit cost, and we're saying, okay, describe only this column. And that returns this value, all of these values in this table, but only for unit cost. And we can get even more specific with mean, median, and possibly more. So here's a way that we can generate a Botson-Wister plot that also shows outliers. So so we have the plot function, and in fact, this is the first instance of matplotlib that we've seen so far. Matplotlib allows you to plot data in simple visual ways. That gives you control on how much on how you want to format the data. So it's approaching 8 right now, and if you would like to go, then I think we've covered a lot so far, but I will keep going. So you're welcome to stay, of course. So yeah, we generated a Botson-Wister plot. So do you recall function arguments and parameters? Well, we're specifying the parameters here. What kind is this? What kind of plot is this? This is a box. This is a box plot. And what does vertical equals false mean? Well, what if we did vertical equals true? Well, we've shown this in a different way. We've changed the axis. Okay, I like the other way better. So we'll do this and figure your size. Well, what if we made it longer? What if we made it shorter? These are just different ways to create visualizations. So there's a good level of control with how you can display. Let's do another thing. Well, again, working with the unit cost, so like the cost distribution, we can display a density graph. And hold on. This, I'm not sure why that didn't work. Oh, here we go. It just took a little while. Okay, and yeah, and this gives a distribution of the unit cost. How do I say 0? I
Wait,
think.
sorry, you could do this for any Excel documents, basically.
I'm not sure if it's any Excel document. I think it has to be in this format. Well, this is a CSV file specifically, and Pandas can work with CSV. I think it can work with Excel, and it can also work with databases. But I'm not sure the entire list of values that or file extensions that Panda can use. But I think you can find a way. It's quite flexible. So here's a lot of code. I won't explain every detail, but just by means of demonstration, let's see what this can do. Well, we've shown the density using this code from before, and we've also specified 2 lines, which are the mean and the median. Okay. Well, the mean is obviously at the peak, and the median happens to be higher than that. Okay, and yeah, so that's an interesting comparison. Let's see what this does. So we've specified a histogram here over the unit cost, and we set the y-axis label to be number of sales and the x-axis to be the dollars. Okay. That's this. Okay. Any questions so far? Any other questions? Okay, so here's some more visualizations. So here's the head again, same as before. Now let's look at age group. So by doing age group value counts, what we are doing is showing all the values of the different, or the count for each value. So the number of entries where the age is adults, where the age group is adults, there are 500 and or 56,000 of those, and as following for young adults, youth, and seniors. Okay. Well, with this data, we can use this. So this is the same as before, and we can plot this using kind is equal to pi, which is, so it's a pie chart, and that'll just display it this way. That's also very nice. Okay, and similarly in a bar, same thing, just in a kind is equal to bar now, and we can also we also have to set the y-axis label. Okay. So so one thing that we mentioned before was trying to find relationships between data and trying to draw information from it. Well, one important information is obviously relationships between two things and correlations. So we can use the function correlation, and that will create a matrix. If there are n attributes, or there are n columns that all have numerical values, then we'll have an n by n table, and that's just showing the relationship. So for these like diagonal entries, they're all 1 because day has a linear relationship with day. Okay. And I guess let's find another example. Okay, cost has a linear or mostly linear relationship with profit. I guess that makes sense. Profit and revenue are also like obviously very, very correlated. I guess the year, like in earlier years, the revenue was less. That's why this relationship is negative. Okay. But this is just numbers. If we wanted to make this prettier, well, here's one way we can do it. And this is just another correlation map where if it's blue, there's a high correlation, and if it's red or tan, it's a negative correlation. If it's red, it's the most negative. Okay. So here's just some more examples. Okay, a scatter plot with these axes. Here's another scatter plot that we can see a linear relationship in. Okay. And here's another box plot, which compared to the previous one, this actually has multiple columns that we're mapping. Okay. So yeah, I won't go through the syntax for this because I don't think that it's essential. Okay, so we also mentioned that earlier on that Pandas will allow you to wrangle data, which was manipulate data, right? So what we've done so far was display data, but we haven't done anything with it. So because of the relational nature of our data, the fact that it's in a table, it's in a two-dimensional table, is really convenient. Because if you want, because all of the similar data is in the same column, and all of the data that's related to each other is in the same row. Okay, so we're gonna take advantage of this column fact. What we're gonna do is calculate a new column, and this is the revenue divided by the customer age. So for each row, it's gonna calculate the revenue and divide it by the age. and it's calling this value revenue per age, which is a little bit weird and arbitrary, but I guess maybe it's showing some relationship between age, or like normalizing revenue per age. I'm not sure the exact implication of this, but if you ever wanted to do that, then you can create a new column and define it as follows. And here's performing head on it, so showing the first 5 values. And using the matplotlib functions as before, we can also perform, we can also create a density plot, and we can create a histogram. Okay. I think that's as far as I want to get for today. I think I've shown everything that that would give a good enough overview of the capabilities of Pandas, NumPy, and Matplotlib. At this point, does anyone have any questions?
I had a question. In the beginning, when you went over like the overview of data analysis, and like the collab thing, you talked about like using, or like you have to like kind of clean out the null data. How would you do that? Like, do you have to do that manually, or can you? Is there like a function that like just deletes everything that's like null?
Yeah. I don't have it on me right now, but I absolutely almost certainly believe Pandas has like the ability to like clean out values from like where a certain column is null. Maybe I can be able to find that out right now. Maybe it's in this one. But if not, I would say that's probably just out of the scope of this this workshop.
Okay.
Yeah.
Cool.
Yeah. There's nothing related to that here.
All right. I was just curious. Anyone else have questions?
Okay. At this point, I also had one other exercise planned, which was apply what we learned here to another data set. But I do understand it's a little late, so I guess it depends on y'all. Like, are we gamed out for tonight, or does anyone want to go for the additional exercise? If not, then I think we'll be closing for today.
Yeah, it's midterm season, so I think I gotta dip too.
Okay, got it.
Yeah. This is really interesting though.
Yeah, it was a really helpful workshop.
Yeah.
Awesome. Yeah, thank you.
I wish I knew this stuff before my last internship, because I think I could have used it. But yeah.
Why don't we end the video right now?
Yeah, I'm gonna stop.